I'm excited for that class, though. It sounds like it's really. I was very enthused by the timing analysis. It's impressive. Yeah. Kind of gets you excited.
Yay! It's working.
I feel like you don't need to say that. You're not gonna be like, I grab my stuff.
I think just keep an eye on the chat, just in case someone asks questions.
What classes are you taking this semester?
Hey guys, let's get started. Okay, this one is still lagging behind, but I think the signal will come out over there fairly quickly as well. So what we are doing today is continue our discussion on ER diagram. Okay. So we talk about. So this is where we have. Okay, so to give you a quick review of ER diagram, which we talked about on Monday. So in ER diagram, we have entity set and relationship set. An entity set is a collection of entities, and we need to make sure this point is on the. Okay, it should come out fairly quick over there. Okay, so an entity set is a collection of entities. Such as in this example, we have an employee entity set which has a collection of employee entities. And since we're dealing with structured data, all entities in follow the same structures, meaning they must have the same set of attributes. The values of those attributes obviously will be different for a given entity, but the structure of entity must be the same for those in the same entity set. And relationship set is basically the interactions between entities from either the same entity set or two different entity sets. If you're talking about binary relationship set, later on we will see ternary relationship set and so on and so forth. And the collection of the same type of relationships give you a relationship set. Like in this case, employee work. You may have relationship set connecting entities from the same entity set. Like in this case, in this particular case, employee reports to another employee. So both ends of a relationship set are entities from the employee entity set. Then we talk about the mapping constraints for a relationship set. In particular, we talk about many-to-many mapping, one-to-many mapping, and many-to-one mapping. And the way you capture that is by using an error in your relationship set. In particular, let's look at this example. Employees manages departments. As we argued, essentially the manager of multiple departments, but each department can only have one manager. So that's a one-to-many mapping from employee to department. Why is that? Because one employee can manage multiple departments. That's many. But from the department side, each department can only have one manager. So that's a one-to-many mapping. And the way you indicate a one-to-many mapping in your ER design is by drawing an arrow coming out from the many side, coming out from the many. In this case, employee will be the one side, departments will be the many side. Any question regarding this? This is just a quick review of what we discussed last time. And if you have no arrow whatsoever, then that's by default is simply a many-to-many mapping. Many-to-many mapping. If I draw this out, this is your employee, this is your department. So what this one says is that I'm going to use the black color for the managers' relationships, the manager's relationships. So what happens is an employee can manage multiple departments. But once you have a manager assigned for a given department, you cannot add this department to another manager. That's disallowed because this is a one-to-many mapping. So this is essentially a one-to-many mapping. So it's possible that this guy, you cannot let this person manage. So this example also tells you that it's possible to have multiple different relationships for two entity sets. So employee and departments, they participate in the managed relationship set, but at the same time, they also participate in this works in relationship set. Okay? Which I'm going to draw using a different color. And that's, by design, is a many-to-many map. Means that, okay, I can work in this department, I can work in this department, I can also work in another department. For example, and this may work in another department, and so on and so forth. So the green is for working, the black is for management. Okay? But one thing that is not captured by this design is whether an employee entity or a department entity must participate in a given relationship set or not. For example, this design doesn't really tell you whether I must have a manager for a given department. So in this case, if you look at black lines, I get rid of the green ones to be clear. I have a department, which is the last one right here, that has no manager assigned to that department. Do you follow me? I also have some employees who are not manager at all of any department. And that's how do we distinguish this from, for example, if I add another line, from this case, where every single department must have a manager. Total participation constraint. What it says is that once you have total participation constraint specified, all entities from a given entity set, every single one of them must participate in that relationship set. Okay? And the way you specify that is by using a bold line like this. Let's ignore this. Just look at this one. What does this mean? This still tells you a one-to-many mapping, meaning one employee can manage multiple departments, and the department can only have one manager. However, in addition to that, this bold line right here tells you it's a one-to-many mapping with a total participation constraint on the department side for this relationship set. What that means is each department must have one manager and exactly one manager. So this actually means exactly one. You must have one manager is indicated by the bold line. You can have at most one manager is indicated by this arrow right here because it's a one-to-many mapping you can only be connected to at most one employee. So combine these two facts together, you get the semantic of exactly one manager. Does that make sense to you? So this means on this side, okay? If I add both lines to it, what does it mean? Message. For, of course, for a given entity on the right-hand side. For a given entity on the right-hand side. Okay? Any question on this? Now, with that understood, let's look at this example, which is the other relationship set in this case, which is works in, and I have total participation constraint on both ends. I'm going to ask one of you to explain to me what that means. Yeah, go ahead. What's your name? Identify yourself first.
Dylan. That means so the bold line on the left-hand side means that each employee works for at least one department, but they could work for more. And then on the right-hand side, that bold line means that each department has at least one employee, but it could have more than one.
Excellent. That's right. Okay, that's exactly right. So I'm gonna repeat what Dylan has just said. So let's consider this. So works in versus both line and both line works in. Okay. What's the difference between the two? As he has just said, what this means is each employee can work for multiple departments, but you must work for at least one department. So the participation for a given employee, if you look at a particular employee, it can be this or this, but it cannot be this. Meaning that you cannot have no relationship attached to an employee. You must have at least one. This becomes okay. One relationship attached to this employee. This relationship means works in relationship. Coming back to this diagram right here, if I have the bold line on the employee end, on the employee side, then this is not allowed anymore. These two employees, they have no green line coming out of them, which is not okay by this design, because you must have a department that you work for. You can work for multiple departments, that's a single employee from the employee entity set. Does this make sense to you? That understood. Now coming back to this end, so we have to fix this, so we will add some green line. I don't really care which department you connect to, but you have to have at least one department that you work for. Okay? Now on the department end, if I do not have the total participation constraint, meaning that this line is not bold, then I can have a department that have no employee working for it. Meaning that I can add the department here. I have a startup idea just now. I think you can design a pen marker that can change color with voice command. Blue, red, color. I think that's a great idea. Anyway, coming back here. So, this is the department. It's okay, I have no green line connect to it, in this case, because I can have no employee work for me. However, if it's a bold line, okay, I have a green line coming out from the other side. In addition to that, because we also participate in the managed relationship set, and which has a total participation constraint on the department as well, in the same time, you must also have a black line connecting to this department. And the difference though is that you can have one black line, but how many green lines can have? Well, you can have as many, but at least one. So potential setup for this department may look like this. Okay? Any questions so far regarding this? Now I'm going to ask you a few questions. Okay? Suppose I have a design like this. I will ask one of you to tell me what it means. Okay? So that's my design. What does it mean? Somebody want to try? Yes, go ahead.
Is this manager works?
Sorry? Go
Is this
ahead.
manager
Oh,
or
sorry. I should specify the relation to that. Yes.
It means that every employee works in one department, and every department has one employee exactly.
Well, not works, managed.
Manages, excuse me,
Yes.
manages, yeah.
So each employee department has one manager, exactly one manager. And if that's the case, that's probably the company you want to work for, right? That's the project manager. But you know what? If you're smart, that's the company you want to kind of get your resume ready or apply somewhere else. Because when I want to become manager, you know, I think the company is doomed. Everybody does the talk, nobody does the do, right? Okay. So next we're going to talk about weak entity, and this, and it's not that commonly used in practice. Okay, so try to understand this, but if you don't, it's not a big deal. Okay. So a weak entity can be identified uniquely only by considering the primary key of another, what we call owner entity. So let me give you an example of this. I have the employee entity set right here, but then I have dependent of that employee. So suppose you're designing a corporation database. You're designing for a particular corporation company. Obviously, you care about employee information. That's set for all the employees of that corporation, of that company. Do you really care about the dependence of those of the employees working for your company? Well, mostly you don't care. You don't care about those data, right? Those are not relevant to the business operation of your corporation. You only care those dependents when, for example, the employee has purchased a healthcare policy that's sponsored by your company, and that healthcare policy is able to cover not only the employee but also the dependents. So you only care about those dependents when this is the case. When this is the case. So in other words, these dependent entities are not really essential entities, are not really a set of essential entities to your design, but you do have to care about them when this condition is met. When an employee entity has purchased a healthcare policy that covers not only the employee, him or herself, but also the dependents of this employee. And that's a perfect case, perfect example where you want to capture all the dependents. A weak entity set, in general, is no different from a typical normal entity set. The only difference is the existence of those weak entities solely depends on an owner entity. Meaning, if the owner entity is deleted from your database, those weak entities will be automatically removed from your database. Not only that, in most cases, weak entities depends on only a single owner entity. But one, so in other words, there must be a one-to-many mapping between owner entity set to a weak entity set. Furthermore, per the argument I just mentioned, you only care about a weak entity, for example, a dependent, if it solely depends on an owner entity. Meaning, as soon as a weak entity no longer depends on that owner entity, you don't care about that weak entity anymore. In other words, you cannot have a weak entity that has no owner entity. What does it indicate? That is on the weak entity side. On the weak entity side. Because every single weak entity must have an owner entity. You cannot have a one weak entity that does not even have an owner entity. With all this argument, we derive this particular design for a weak entity set, which is it must have an owner entity set that it depends on, and must be a one-to-many mapping between the two, and weak entity set must have total participation constraint. Okay? So you do. But how do you distinguish this from a normal entity that happen to have a one-to-many mapping and total participation constraint? Such as employee managed department, an employee on this managed relationship has a one-to-many, and department it has a total participation constraint. Every department must have a manager. Well, the way you distinguish that is on the weak entity set, the key, typically you indicate the key attribute for an entity set using solid underline, right? For that attribute. For weak entity set, you use dashed or dotted for the key of that entity set. Okay? If this is somewhat confusing to you in your design, typically you don't have to use weak entity set. You can just treat them as a normal entity set with one-to-many and total participation constraint. It will work just fine. Okay? We talk about binary relationship set and ternary relationship set, and even possibly extending this to a relationship set that connects more than 3 entity sets, right? So let me give you an example of that. Suppose I have the design on top. Okay, I have employee one-to-many mapping between the two. But not only I want to know that an employee covered which set of dependents, I also want to know he or she, the employee, is covering those dependents using which particular healthcare policy. I may have multiple policies available. In fact, you can imagine maybe an employee may have purchased more than one healthcare policies. It's rare, but it may happen. Right? For the argument's sake, let's imagine you can purchase multiple different healthcare policies, and you use one of them to cover your dependents. Does it make sense to you? So with that argument, what do you get? First of all, you have a one-to-many mapping between employee and dependents, because one employee covers multiple dependents, but each dependent has at most one employee to cover the dependent for. Okay, so that's a one-to-many mapping. An employee may purchase multiple policies. And here, I assume a healthcare policy has a unique ID. Each policy is owned by a single employee, but an employee may have multiple policies. So that indicates a one-to-many mapping between the two as well. Question?
Why would you not also have policies?
Why? Can you speak louder? Why do you have policy as?
Why is the policies also not a weak entity?
Oh. Why? The question, let me repeat the question. Okay? The question is, why don't we consider policy as a weak entity set as well? In this case, you have a response?
Yes, because you want that in, persist in the database because somebody else might have purchased that.
Okay, that's a good response. I know what you're gonna say. Let me see what I think. Let's see whether that conforms with yourself. So there's a clarification I need to make right here, which is the response is actually an excellent one, but subject to a subtle clarification that let me try to clarify. If you view policy as something that all employees may be able to purchase, then what she said, by the way, what's your name?
No.
Okay, is right, because even if you own that policy, somebody else may still own the policy. So that's not a weak entity set. Okay? But I think what he's referring to, and in this particular example, as I was trying to explain, is that when an employee purchases a particular policy, I view that as a unique policy owned by that particular employee. So it's not really a general set of policy principles, but it's really just one specific policy customized for that employee. So in that case, what's his name? Shane has a point in the sense that once the employee no longer owns that policy doesn't exist anymore. Does that make sense to you? So yes, theoretically speaking, you can treat this as a weak entity set as well. But look at this example. I'm not even so the point is, in this particular example, I'm not trying to illustrate weak entity set. I'm trying to illustrate the relationship between binary and ternary relationship set. So you could definitely treat this as a weak entity set if you wish. Okay, that's a good discussion we have. Okay, now coming back to this particular case, let me stop. So you have one-to-many mapping between employee and policy, one-to-many mapping between employee and dependent. So far, everything is good, but now as soon as you have those two one-to-many mapping in place, some other person come and look at your design might get confused because this design, which is not your intention, but imply a one-to-one mapping between policies and dependents. Clearly, that's not what you want because one policy can be used to cover. Do you follow me? So this has a consequence of introducing ambiguity, a potential ambiguity right there in your design, using a ternary relationship set approach. So how do you get rid of that ambiguity? Meaning, I want one-to-many mapping between employee and policy, one-to-many mapping between policy and dependents, and one-to-many between employee and dependents. I want to capture all three without introducing any potential ambiguity in my design. How do I go about doing that? Well, if you try to satisfy all these constraints, a binary relationship set, as shown, as illustrated by the picture down below in this particular slide. So you can have policies as an entity set, employee, one-to-many mapping between employee and policies, and one-to-many between policy and dependents. And dependents now become a weak entity set depends on the policies rather than on the employees directly. And if you check this design, it gives you a one-to-many between employee and policy, then one-to-many from policy to dependents. And automatically, if you have one-to-many, if you think about it, one employee so one employee may have multiple policies. So that's a one-to-many mapping we argued. And a policy may have multiple dependents. And this, if you look at, so from here to here is one-to-many, but then from here, employee to dependents, that's one-to-many as well. If you have one-to-many for both of them. Right? You have a question?
Yeah, so I'm sure you're going to do this, but I was just wondering how can it be with a weak entity set if we're using, say, I guess, which I would assume is probably the policy ID on that side, but if we're relating using the policy essentially as the key for dependents, if keys are supposed to be unique, how can we have...
The weak entity set has its own keys. So the key for the dependents are, so in this case, policy name is used as a key for the dependents, okay? So you have a point, meaning how do I distinguish a particular individual dependent in this case? Is that what you're trying to argue?
Yeah.
Okay. So that's a good point. I mean, in an actual design, you should have a dependent name or something like that. to distinguish among dependents covered by the same policy. So that's a good point. But typically the key from the owner entity set as the key for the dependents together. So in this particular case, what will happen is, so you have dependents, right? So you have the policy, you take the key from the policies, policy name or policy ID, and you will add to it another thing like dependent name. And this together will be the key for your weak entity set. Is that the question? Okay. So in this example, we show the design where it is important to use two binary relationship sets rather than a single ternary relationship set to model interactions in your database. Okay? This may trigger you to ask the following question, which is, isn't the case that we can always just use binary relationship set to represent a ternary relationship set? In particular, we use two binary relationship sets to represent a ternary relationship set. Then let's get away with ternary relationship set at all. We don't use this ternary relationship concept anymore. Two binary relationship sets, right? So you may think about, it may be tempting to do just that. I'm going to give you yet another example from the other side, which is there are cases where you have to use ternary relationship set, or even more than 3 in some cases, right? Where you cannot use two binary relationship sets to represent a single ternary relationship set. And here is an example of that. So let's say I have this particular setup. Okay, it's a manufacturing database. Okay, I have parts, I have departments, I have suppliers, and I have a single contract, 3 entities, one from each of these entity sets, which represent what? Represent the interaction among them, which tells you which department is contracted to order which part from which particular supplier. Okay, so this contract really has 3 pieces of critical information. It tells you which department makes the order, which supplier gonna supply to the order, and for which particular part. So that's the design on top. And in addition, you may have attached to the relationship set, just as you have attribute attached to entity set. In this case, I want to know the quantity for a particular contract. Okay, you order this part from this supplier. How many? That's not particular to the part, that's not particular to the department, not particular to the supplier, but it is a particular information attached to a contract. So that should be an attribute to the relationship set rather than to any of those entity sets. So that's the design on top. So let's try to replace this design like we did here using several binary relationship sets. And supplier can supply that part. That's not good enough. I also need to know, for this particular part, maybe multiple suppliers are able to supply that part. I want to know which particular one you have dealt with. So fine, I add another binary relationship set on this side, which is departments deal with a particular supplier. But even with all this relationship set in place, you still cannot guarantee that this department is getting this part from this particular supplier. Does it make sense to you? Give you a simple example. So let's say this is one department that needs these 2 parts. And this supplier can supply this part. Yet another supplier can supply this part too. And at the same time, this department has dealt with, you still don't know which is the supplier that under this contract is going to supply this particular part for this department. In the ternary relationship set, what happens? In the ternary relationship set, I have a department I will have supplier, I will have part, and there will be a line connecting three of them. And that represents an interaction among three of them. And this line represents a single contract. This line represents a single contract. Does that make sense? So that how get rid of that ambiguity, potential ambiguity you have. So the summary is, the rule of thumb is, it's really a case-by-case design analysis you have to do. There's no golden principle you can apply always. Okay? Really, you have to do a case-by-case analysis. Okay. All right. So those are the basics part, the basic concept of ER. So let's talk about some of the more advanced constructions in ER diagram. So the first one is a hierarchies. So if you guys have some experience with object-oriented programming, this is actually not that hard to understand. What this does is to give you something like inheritance in an object-oriented programming concept. So for example, I may have employees as entity set. So I have a set of employees working for my corporation or company. However, I do have different subgroups within those employees. In particular, for the argument's sake, I have hourly employee who works for the company by hours. So I pay them based on how many hours they work for me. They have hourly, we have work for. On the other hand, I may also have some long-term employees, what I call contract employees, which is under a contract rather than working by hours. Obviously, both groups of employees are going to share some common attributes that you care. For example, their name, social security number, lot, I don't know, like office lot, which particular lot they were assigned to work, the desk they work on. So those are the common attributes you care about. If you have some group-specific attributes, you care for each group. Hourly employee, you care about the hourly rate and how many hours he or she had worked for your company. But you do not care about those two attributes for contract employee. But for contract employee, you care about contract ID, maybe some other attributes, which I'm going to omit from this example. So if I ask you to do this using an object-oriented programming approach, you all know you're going to design a parent class called employees with attributes such as social security number, member variables, social security number, name, and lot. And you're going to have children classes, two children classes, in particular case, our employee and contract employee with specific attributes. Similarly, in ER, you can do something similar, which is, but we don't call this inheritance, we call this a hierarchy relationship. But this is the special relationship that's different from a normal relationship set connecting two entity sets, as you can tell. Okay? So it's very different. And once you have a design like this, you may have some additional constraints specified to get rid of potential ambiguities. One is what we call overlap constraint, which means if you think about this as two sets have overlapping elements, meaning, in other words, can an employee be an hourly employee and a contract employee at the same time? Can this guy appear on both entity sets? So that's what we call overlap constraints. You can either allow or disallow that. Okay? How do you indicate that? Well, you just add a text notation to design, say overlap constraint allowed, overlap constraint disallowed, to clearly indicate whether you allow an entity to be on both entity sets or only one of them. So that's overlap covering constraint, which says if you look at the union of hourly employee and contract employee, you look at the union of these two entity sets, that they really give me all the entities from the employee entity set, or it does not give me all the entities from the employee's entity set. And that's what we mean by covering constraint. When covering constraint is true, that means the union of hourly employee and the contract employees represent all employees you have. Otherwise, you may have some employee entities who do not belong to either. That be possible in practice? Well, suppose you have new employees, you haven't decided, you are interviewing a potential candidate, you are considering a probation period or whatever, internship period. It's not a contract employee, obviously, and it's not our employee yet. We are still making that decision. So for that time being, that particular candidate will be in the employee entity set, but not on any one of the children entity set. Okay? Aggregation. So far in our discussion, we said a relationship connects two or more entities. Okay? You can never have a design like this, which is you can never have a design that's like this. Meaning you cannot have a relationship set connecting an entity set to another relationship set. Does that make sense to you? Because this is actually fairly intuitive. This doesn't make sense in practice because if you were to have a design like this, let's assume if you were to have a design like this, what this means is you have an entity that has a relationship. Suppose that's what it looks like. You're going to have another entity set at the top, another entity set at the bottom, and some relationship among them. So this is this, right? And then what you design is saying is that, okay, there's one entity that connects to some relationship like that. And really, what you should do is simply get rid of this and make this a ternary relationship. And that should be what you have done in the first place. In other words, you cannot have relationships that connecting an entity set to another relationship set. That's impossible in the R diagram. Okay? However, there are cases where this may arise that demand you to connect entities to a collection of entity and relationships. Let me give you an example of that. Let's say I have departments, I have products, and I capture the interaction between them using sponsor's relationship set, which simply tells you, so department has budget, right? And department makes decision on what product I want to work for. So I allocate my department budget to a set of products, and each product has a budget. Does that make sense? So department sponsor product. And suppose this is a many-to-many mapping, meaning one department can sponsor multiple products, and a given product may receive interest from multiple departments, so my product budget is coming from multiple departments. Each of them contribute a little bit. So it's a many-to-many mapping between the two. Okay? Since money is involved, some kind of we must have some kind of audit in place to make sure every single dollar is well spent, right? So I want to have some employees, let's say accountant or auditors, to monitor what's going on between department and product and this sponsorship. Obviously, this employee is monitoring not the product, not the department, but rather the interaction among them. Does that make sense? So this kind of implies that you want to have a relationship that connecting that to the sponsor relationship set. But ER diagram does not allow you to do that. So what's one possible way of doing that, which is to use aggregation. What you do is you use a dotted box to enclose a complete interaction between entities, meaning the entity set and the relationship set. You enclose them, and that becomes what we call a conceptual entity set. And then once you have a conceptual entity set in place, you can have another entity set having relationship set with this conceptual entity set. And this particular technique is what we call aggregation, because you are aggregating two entity sets and okay? So you may wonder, what's the difference between aggregation versus ternary relationship? Okay? Can I simply use, in other words, can I, instead of doing this, can I ignore the monitor's relationships at all, simply do connect employees to the sponsors relationship set, and that makes sponsors a ternary relationship set. Can I just do that? Can I do that? Well, in most cases, that would be fine. However, this aggregation approach gives you more flexibility. For example, in this case, in this particular design, the monitor and this whole sponsor interaction is a many-to-many mapping, meaning I can have multiple employee, multiple auditors assigned to monitor the interaction between departments and products. I can also have one product have multiple auditors assigned to it. If I wish, I can design one-to-many, many-to-one. And if I were to use the ternary relationship design, as soon as you start doing this mapping constraint, you will end up with potential ambiguity just like you have here. Does that make sense to you? Right? It's exactly the same situation will arise. So having aggregation will be handy in that case when you try to monitor different mapping constraints between the two. So that's kind of like one example why people need design like aggregation. But typically, aggregation and weak entities are you don't see them very often in practice. Okay. That's pretty much all you need to know for ER diagram. And you will be surprised using this seemingly very simple and intuitive tool, how complex design you can try to model. Okay? You can pretty much model very complex interactions in real-world applications using this seemingly very simple design. Okay? Of course, ER diagram this can be tricky because there are no one absolutely right answer for a given design. User requirement, different people may come up with different designs. Oftentimes, you may find multiple designs all work okay. It's kind of hard sometimes to argue which is the best. Depends on the different design choices people will make. For example, should a concept be modeled as entity or attribute? I'll give you a simple example. Suppose I have an employee entity set. Okay? Employee entity set. And I want to know the address information for a particular employee. Address information for a particular employee. Should address of the employee entity set, meaning every employee entity will have an address as its attribute, or should I model address as an entity set by itself? Okay? If you look at your employee, this really is data dependent, right? If, let's assume we're in Salt Lake City, then it makes more sense to model address as an attribute to employee. Why? Because I would expect most employees have a unique address. People typically in an apartment building here. However, if you're going to New York City, okay, many employees will be living in an apartment complex. And I want to know some particular structure information about that apartment complex. Meaning many employees may be mapped to the same address entity. Then it makes more sense to model address as an entity set rather than an attribute for the employee entity set. Does it make sense to you guys? So really depends. Yeah, go ahead.
How easy with the tools that we're going to be using, would it be to change up the design? In other words, is this a really critical part right at the beginning?
Good question. So let me repeat the question. Right? The question was, how easy is the tool we're going to use for ER design to make change like this, or this is really a critical choice you have to make at the beginning? Meaning that later on you realize, oh, it's better to go with that design choice instead of the design choice I started with. How easy it is to go back and change my design. Okay, there are two parts to this question. One is, if you talk about the tool you use to draw your ER diagram, right? There are obviously commercial software that facilitate you to draw, professional-looking ER diagram, like rational rows from IBM. They use something called UML. I think it stands for Unified Modeling Language, but essentially it's a variation of ER, and it's a commercial software. It's fairly easy to change your drawing, right? But I think the fundamental question here is not really how easy it is to change your design in this particular drawing tool. It's really later on when we come to the very next thing I'm going to talk about after ER is once we have these ER diagrams, we're going to convert this to relational models, which are the tables you typically see in a database. And once the tables are fixed, especially you have data populated into those tables, it's become kind of expensive to change your design at that point. So it's fairly important, it's really important for you to iterate over multiple times of your design. Make sure you have a reasonably well designed so that later on you can minimize the amount of changes that you may need later on. So design is critical, right? Design is critical. So you can ask similar type of question like, should a concept be modeled as an entity or relationship and so on and so forth. I'm going to give you, so address, I just talked about that. What about entity versus, let me give you another example, entity versus attribute. So address is an example where you're making the design choice of whether it is the attribute for entity set or entity set by itself. But what about attribute versus entity set when it comes to attributes to a relationship set? Like I said earlier, a relationship set may have attributes too. So for example, in this case, employee works in department, and I want to know of that employee working for that department. So very natural design is adding two attributes to the relationship set, to the works in relationship set. Tell you, okay, employee works in this department from this date to that date. Very natural design, right? You know what? The second day, so you are the database guy working for this company. You finish your design, you're happy, you go back, having your coffee. Second day, HR person call you, like always, right? You know what? We have employees may have worked in the same department but multiple different times, right? So but that totally destroy your design on top. Why? Why is that the case? Why the design on top no longer works? Okay, to understand that, we look at what's really going on, right, with this design. If you have a design like that, what happens is this is your employee, this is your department, and it's many-to-many mapping. So employee works for a department. So it kind of looks like that, right? Okay? And each relation into a relationship, right? This represents a single relationship. And you may have two attributes attached to it, meaning so each of these has from and to. That make sense? So you can have two values for a relationship. If an employee is going to work for multiple different periods for the same department, how are you going to model this? Well, you may argue, what about, let's say this guy, this particular guy, works for this department twice. The first time from January 1 to February 1. The second time from May 1st to July 1st. You may argue, that's not hard. Let me just do this. Add another line, another relationship. Says I said May 1st, May 1st to July 1st. Isn't that okay? Well, unfortunately, that's not okay. The reason for that is, keep in mind, what ER says is, for two entities, with respect to the same entity set, there can be at most one relationship from that relationship set connecting the two same entities. So once you have one relationship set one relationship connecting the two entities, of course, with respect to the same relationship set. If you have another relationship set connecting the two entity sets, yes, you can have another relationship among the two, but with respect to the other relationship set. For the same relationship set, you can only have one single relationship connecting the same two entities. That make sense to you? So you cannot have multiple relationships from the same relationship set connecting the same entities more than once. You cannot do that. You may wonder why I cannot do that. Why it doesn't allow me to do that? Why it doesn't allow me to model that? Well, the reason is, we're going to talk about relation model later on, which will become crystal clear by then. But I can tell you, give you kind of like a preview why this is not allowed. The reason is, each of this line, right now it's just a single line. But later on in your database, this represents a specific record, a tuple, right, in your database. And you must be able to somehow distinguish every single line right here. Or in other words, you need to uniquely identify a single record in your database. How do I uniquely identify this line? Well, it represents interaction between two objects. And each object has a key. You can think about each object has an ID. So this has an employee ID, this has a department ID. So to represent this line, I simply use employee ID and department ID. So my design for this schema is simply employee ID and department ID. That will be good enough for me to capture what's going on here. But once you start allowing multiple relationships to exist for the same entities, with respect to the same relationship, what's going to happen? Well, you lose that unique identifier, which is a combination of the keys from the two entities. You may wonder, okay, what about I add another attribute like a count? That's 0, 1, 2. So for example, employee ID 1, department ID A, I can have 1A0, 1A1, 1A2, and so on and so forth. The problem is, how many counts should you accommodate? You don't know. In your design phase, you have no way of knowing, and it may change with your specific data. And that goes against the principle of structured data design, which is the structure of the data needs to be fixed, regardless how the specific data looks like. It really should capture the intrinsic interaction among those objects, rather than the specific data values. Okay? So that's why we cannot allow multiple relationships for a given relationship set. So how do you actually capture this? Well, a better design, once you know that's the case, what you should do is to treat this duration as an entity set by itself. So I'm going to add another entity set on top called duration. Each entity here represents a time period. May 1st to July 6th, that's a time period. So on and so forth. Each of the entity over there represents a specific time duration. Now it's okay, right? An employee may work for this department once. He or she can work for that department another time. That's okay. So I use a ternary relationship set to accomplish this particular objective right here. Does it make sense to you guys? Okay, cool. And let's give another design choice example, which is entity versus relationship. Sometimes this is not clear from the user requirement. Okay? Let's consider the design on top. Employees, managers, departments. By the way, I call this manage too to distinguish the discussion here from the earlier example where I show employee managed department. Okay? And I want to know, okay, which period you manage that department. And what's the budget you were given to manage the department. So I can ask you to be a manager of a department, but give you $0. You probably won't be happy about that. Right? So I will give you a budget, okay, for that department. Well, that is okay. The design on top is okay. if, first of all, it's a one-to-many mapping between manager and departments. So a person can be manager of multiple departments. A department can only have one manager though. The design on top is okay if you have a separate budget for each of the department you manage, and those budgets are supposed to be destroyed. You're never going to use budget for department A on department B. Does that make sense to you guys? I see some puzzle face. Okay, I see some puzzle face. Let me try to draw this out. Okay, so the design on top says it's better to use this. So an employee may manage multiple departments. That's okay. But each department can only have one manager, and each has two attributes. As the budget is 1 million, and this budget is 2 million, and period is January 1 to I don't know everyone, and for the same period. Okay. Okay. So you manage that department, these two departments for a month for 1 million, 2 million. You know, good job to have. Spend 3 million in a month. Okay. All right. So the design on top will be good for this case. But one important constraint of this design is what? You cannot use any dollar from this 1 million on department, let's say this is A, B. You cannot use any dollar from here on department B, and vice versa. You cannot use any dollar from department B budget on department A. Does it make sense? But let's assume my organization, if you look at Google and things like those companies, they do not have this vertical partition anymore. Rather, they form this ad hoc concept department and the project that I give you an overall total budget, and you may manage multiple projects, and it's in your discretionary power and the manager to decide how you allocate your budget, total budget, to different projects. Does that make sense? So instead of have 1 million, 2 million specified at the beginning, I give you 3 million in total for department A and B. And you go ahead and figure out how you want to spend those money as you wish. 1 million, 2 million is okay. 2 million, 1 million is okay. 0, 3 million is okay. If department A employee are really mean, okay, $0, 3 million over there. So if that's the case, that's a design choice between entities and relationships, right? Why I said that? Because in this case, manage is a relationship set. If I realize that's what I want to do, which is a total budget, I cannot use this design anymore. Rather, I should introduce an entity set called manager appointments. Does that make sense? So employee and manager appointment, this is one-to-one mapping. An employee is assigned to a particular appointment. And this appointment may contain multiple departments, which is one-to-many mapping between this, and there is a total budget for that appointment. Does this make sense? So it's a one-to-one mapping between manager, employees, and appointment. And this appointment, you can think about this appointment as an email from your boss, right? Dear XXX, congratulations, from this day to this day, you are appointed as manager for department A and B with a total budget of 3 million. That's your management appointment. And that's a one-to-one mapping. And then from this appointment, it's a one-to-many mapping to multiple departments, single budget, and you may have different appointment periods for each of the departments. That's okay, because I can still keep this as an attribute to the relationships rather than an attribute to the entities. If you have the same appointment duration for all the departments you manage, you can treat this as an attribute to this entity set. But if it's specific to each department, you should treat this as an attribute to this relationship set rather than having this as an attribute to the entity set. So there are all these subtle issues. As you guys can tell, this is not trivial as simply joining a few boxes, right? So it is not that trivial. the things can get pretty hairy, right? For example, I give you a simple design. This is from Kiva website. Power Interior Bureau of Land Management, whatever. So they don't use the particular same shape as what we are using here, but essentially the ER diagram. And this looks pretty complex, but if you look at here, it's actually page 1 of 2. So design is way more complicated than what I've shown here. Summary, I can skip this. Let's move on to the next lecture. By the way, before I move on to the next lecture, I'm going to show you homework 1. I have released homework 1, which is due the Monday after next week. So it's not the coming Monday, but the Monday after. I think the coming Monday is it a holiday? Yes. Which is too bad. But, all right, so we lose 1 lecture. So it will be due the Monday after. So you have 1.5 weeks to work on it. This particular homework, you cannot finish all parts yet because there are certain parts we haven't covered yet, which we are going to continue after I briefly explain the homework to you. But there are already a big chunk of the homework you can start working on already. So basically, problem 1 and 2 give you a user requirement. You can think about this as user requirement document. Basically, if you guys later on go and do an internship or go working for a company, this is pretty much what you will get. Your manager will write you an email or print out, or even handwriting on whiteboard, tells you, oh, this is what I want, blah, blah, blah. For example, healthcare database for every person, I need this and that. I need to know who is the father, who is the mother, what kind of tests you have done, and so on and so forth. Design the database form. Okay, that's what you're given. In the second case, you have an auto repair mechanical shop. Suppose you are running your own employees, running your own business, and you try to set up this database for managing your employees, technicians, accountants, cars coming in, different models, what tests has been done on a particular car, which technician is good at which model, and so on and so forth. So you will have this specification, design the database. Again, it's the same requirement, right? So the very first step in all of these tasks is to do the ER analysis as what we have done. So, which is what you can start working on already. So why don't you guys start working on the ER? Then I will continue. We still have some time left for today's lecture. I will continue on discussing the relational model. The next step after you've done your ER is to convert your ER design to relational model design. I'm hoping by Wednesday, which is a week from now, you finish the ER design. So on Wednesday's lecture of next week, I will finish the discussion on relational model and converting ER to relational model. Then you are able to finish the rest of the homework 1. Then it's due the Monday after. Okay? So that's your homework 1. Let's come back to any question on homework 1? Go ahead. Yeah.
Are any of the homeworks or projects going to be group assignments, or is it all individual?
No.
Okay.
So that brings up a good point. I used to do, for all written assignments, first of all, I never do group assignments. And I used to do group assignments for projects. Then I once, 1 year when I was teaching this class, I realized that's really a bad idea because you're always going to have groups, especially for class of this size. You're always going to have groups coming back, pointing fingers. Then I have to be the judge, and I don't like that job. Okay? And it's your word versus another person's word, who has done what and who has done what. You know what? Each of you should do this on your own so that you can learn, because you have no force to fall back on. So may the force be with you. Okay? Use the singular in this case. Okay? No group word. Okay? You have to do everything on your own. The other thing I forgot to mention, I made 2 things since Monday. One is I sent a request to the library such that textbooks are gonna be held at the reserve desk at the library, and each of you can borrow out, check out from the reserve desk for up to 4 hours. So that gives you guys a chance to just go and borrow the textbook and view it for 4 hours, and then return it. So somebody else, if there's another person in line, they can get a chance to view it. Otherwise, somebody may check out the book and hold it for a few weeks before another person can get a copy of it. So that's the first change I have requested. The second one is I forgot to mention we also have, in addition to homework, project and the final midterm, we have quiz in class as well, but don't panic. The quiz will be carried out in class in smaller chunks, meaning partition the lectures into different groups. For example, the first few lectures after we are done, I will do a quiz. And the quiz is going to be exactly the same setting as the midterm and final, but it's not taken into, I will not count quiz score into your overall grade for the class. So the purpose of the quiz is to give you a way to gauge yourself in a kind of like exam setting to test whether you know the material or not. And I'm not going to grade your quiz. Rather, what I will do is I will distribute the quiz to you, do it in class, typically 20 minutes. When time is up, I will just stop you and I will go over the solution right away. Then you will score yourself for the quiz. Okay? So that's the quiz. And one more thing is, I forgot to mention on the class website, if you think the homeworks, the quiz I gave you are still not enough, which I think is unlikely, but if you are that type of person, you like to exercise a lot more, I posted the solutions to all number of questions from the textbook, for every single chapter we're going to cover, in a PDF file right here. So you can, if you can get hold of the textbook, and if you want to exercise a little bit more, you can do the question after each chapter, but only do those odd number of questions so that you can check against the solution right here. Okay? And regarding the textbook, let me make it clear. The price of the textbook is pricey. It's about $180 on Amazon.com. If you buy the new one, maybe the used one is cheaper. I mentioned this on Monday. I will say this again. I don't think it's absolutely necessary for you to buy the textbook, especially now I make textbook as a reserve in library. I think, if you're interested in reading the textbook, just go to the library, check it out for 4 hours, either do the odd number question or just read the text, should be sufficient. You don't even have to rely on the textbook. If you just read the lecture slides, come to lectures, do the homeworks, and come to the quiz, you will be totally fine, trust me. Okay? So, again, that investment is up to you. It's you deciding whether to invest $180 on that book or not. But I just want to make it clear, I will do all I can so that it's not absolutely necessary investment from you guys. Okay? All right, so let me continue on here. So, we talked about ER diagram, but clearly database system do not understand pictures. You draw your ER diagram, show it to database, magic is not going to happen. At least for now, things are changing quickly, right? In computer vision and in artificial intelligence, machine learning, deep learning techniques are growing like exponential speed. Maybe one day you draw your ER diagram, show it to the computer with a camera. 10 seconds later, your database design is there. Okay? It's possible, totally possible. But at least it's not there yet. So, and plus, even if that's possible, you want to understand what's going on, right? You want to be in control. You don't want to just say, oh, do this at the black box, then whatever. You want to understand what's going on in that black box. And that's why we want to introduce the next thing called relational model. So relational model essentially is used by most database vendors, like IBM, Microsoft, Oracle, MySQL, PostgreSQL. All these database management systems use relational model, which is what we're going to discuss next. There are some other alternatives in the literature, such as object-oriented model, network model, and so on and so forth. And those are by far way less popular than relational model. So we're going to focus solely on relational model. And later on, towards the end of the semester, as I mentioned, I will also talk about NoSQL, which is mostly for unstructured data. And relational model is mostly for structured data. So relational model give you a relational database. And the definition of a relational database is surprisingly simple. Relational database is nothing else but a set of relations. Just like airport or airbase is a set of airplanes. Right? Same thing. Okay? Same deal here. It's a set of relations. And each relation, people also call that as a table. A relation can be viewed as a table as well. Why is a relation a table? That's because it just looks like a table. And it has rows and columns. It has rows and columns. The columns of a relation is what we formally call as the schema of a relation. Schema of a relation. And the schema of a relation specifies two things. First of all, the number of fields or number of attributes and the type of each attribute. The type of each attribute. And the rows of a relation, of rows in a table, is what we call the collection of rows of a table is called the instance of that relation. The instance of that relation. Okay? And the number of rows is what we call the cardinality of your relation. To give you a simple example, this is a relation. Looks like a table, has two-part columns. That the set of columns form your schema, and the set of rows is what we call the instance of that relation. In this case, I have 3 rows representing 3 specific records or 3 specific tuples of this relation. Okay? And in relational database management system, in relational model, the schema is really, really important because schema specifies the structure of a relation. Once I know the columns on top, even without saying additional records, I know if you're going to insert another student record into this table, that record must follow the same structure as specified by my schema. Now you have a better understanding of what we mean by structure because even without saying the actual record, I know the structure of those records. You must have, for example, you must have student ID, you must have name, you must have login, you must have GPA, you must have age, but nothing else. Not only that, one thing I omitted from this example is the type of a particular attribute, which is essentially, recall in the discussion in ER diagram, I said something called domain of attribute, which represents the same thing. The domain and the type of attribute basically tells you the set of possible values a given field can take. Okay? So for example, SID, in this case, I can spell SID as an integer, name as a string, login as a string, age as integer, and GPA as a real number, which means you cannot have 18.5 as a potential value for age. So the cardinality in this case is equal to 3 because I have 3 rows in my instance. There's another terminology which is less commonly used called aggregate, which basically tells you the number of fields. And this is, by the way, this is not a history class, so you don't have to remember all. Number of rows is cardinal, number of arity cardinal. It's just for your information. You don't have to memorize this at all. Okay? A fundamental question you want to ask for a relational model is, do all values in each column of relational instance have to be distinct? Okay, do I have to have distinct values on these columns? I leave that as a take-home question for you to ponder about, and we will continue on Wednesday of next week. All right, see you guys.